Try again. So we back all the way up. So this idea has been around ever since man has had something that they needed to keep track of, right? Sheep, for instance. What has not always been around is the symbol or the digits that we use to represent that idea of one, having one sheep. Make sense? So, the cool thing about it is, in ancient times, all over the world, math is developing in different areas of the globe. The main areas are in Asia, in Babylonia, ancient Babylonia, in Egypt, and in South America. Okay? So here are some different digits to represent 0 through 10 in different systems. We are going to learn Babylonian, Egyptian, Mayan. We're going to do a little bit of Roman. Hindu, Arabic, these two are the ancient predecessor of our Hindu-Arabic numerals here. So these two came together when two civilizations came together and created the ones that we use today. Okay? So, we are going to start with just what is a numeration system. It's basically a set or a group of people that come together and agree on a common system to represent those ideas of number. That's all that means. They've agreed on a set of symbols and they've agreed on a set of words, and that's what they're going to use. Make sense? Like, everyone in here can count, every kid can count to 5 usually by their 3rd birthday, right? Lots of kids, especially, do I have any Sesame Street kids in here? Did you learn how to do it in Spanish on Sesame Street? I did when I was little. Or reading Rainbow. Did anybody else do that one? No? Uno, dos, tres, cuatro. I mean, I learned how to count in Spanish by Sesame Street. How about any other languages? Do you know how to count in any other languages? Up to 5. Usually, if you ask your kids in the classroom, somebody will know how to do it in Japanese because somebody takes Taekwondo or karate and they learn how to count to 5 in that language. So almost always you'll have a kid that can do that. Especially over in Oklahoma, if you teach in a school that has a high Cherokee or Choctaw population and those students are involved in their community centers, they'll be able to count in their native language. Does anybody in here know how to count in Choctaw or Cherokee? Believe it or not, I can count in Eskimo. I'm Choctaw and I can't count in Choctaw, but I can count in Eskimo. Yupik Eskimo is a Daljik, Malaga, Kapayan, Stamen, Tapiman. I can count to 5, I know! That's as far as I can go. 6 is really long. I can't count to 6. My son's somewhere in the building and he can, but I can't. So, we're going to talk about the development of all these different languages over the next week. And what makes one numeration system different than another numeration system, and what makes each of those different than ours. The reason we learn this is because the biggest job of yours as an elementary school teacher is the understanding of the decimal number system. Nothing else works. Algebra doesn't work. Chemistry doesn't work. Physics doesn't work. Computer programming doesn't work. Nothing else in their life they want to do will work for them unless they understand place value. Does it make sense? Because that's the crux of our number system. So, I'm going to break down your ideas of place value and have you learn it like they do in a different base system. So it will deepen your understanding of base 10. Make sense? Okay, just have an open mind and we'll begin. Good? Okay. So, I went over the definition. The very very first thing that we teach our littles in kindergarten, right, is we start teaching them how to tally when we count things. One of the reasons we do that, it's one of the earliest forms of numeration where they would actually draw lines in the dirt to try to convey or keep count of how many sheep are coming through the valley at the time. They would keep count that way. It's one of the earliest things we do with our kids because it promotes one-to-one correspondence. Do you know what we mean by one-to-one correspondence? Okay, that's a perfect question. Students develop their idea of number through a specific set of stages. The very first stage is just learning what the numbers are called. Those are your calling. They're calling out the numbers in pre-K, right? 1, 2, 3, when they count to the lunchroom, 4, 5, 6, when they're just counting. They actually have no idea what those words mean yet. With me? The next level of understanding is for them to understand that each one of those words they were saying represent a set of objects, which goes back to our set chapter, right? So when students have developed one-to-one correspondence, they can take a set of items and literally go 1, 2, 3, 4, and understand that each one of those then changes that idea. You will see kids in kindergarten with their teddy bear counters going 1, 2, 3, 4. They can count and they know physically what they're supposed to be doing, but that click has not made it yet that word represents an actual group that's a certain size. One-to-one correspondence. You with me? Tally marks help promote that one-to-one correspondence. It also helps them because each group of tallies represents one of their hands, so they can relate to that. It's one of our earliest forms of numeration system we do with them. With me? Okie dokie. So, if we had to do 24 with tally marks, we would have 4 groups of 5 and then 4 leftovers, right? I talked about this at the very beginning. In our system, we have 10 digits. The order of those digits, how many digits there are, is how we represent every number known to us, known to man. We good? Okay, we can do it all with just those 10 digits. The number comes in, that's me talking about it some more. Place value, we have our units or our ones place, right? As we move to the left, each place value is a larger value of 10. So this is actually 10 to the 0 power, 10 to the 0, 10 to the first power, 10 to the second is your hundreds, 10 to the third, your thousands. As we go on, what increases? The exponent increases by ones, which therefore increases each place value by, what's the base? 10. Base 10. Our Hindu-Arabic system is base 10. Did you know that the word decimal actually means base 10? That's what that word means. The word for base 2, like what we code computers, that word is binary, right? Base 16, hexadecimal. Base 20, decidecimal. We have words for lots of them. Native languages, oftentimes native numeration systems will be some type of base 5 or a base 20. Like the Mayan system has base 20 in it. The Inupiaq Eskimo, where I lived for the last 8 years, theirs is a base 20, sub base 5. So the first 5 digits have their own names, and then everything after that is like 5 and 1, 5 and 2, till you get to 10. And then 10 has its own name, and then it's 10 and 1, 10 and 2, all the way up to 20, and then 20 gets its own name, and then it starts again. So that's how you get base 20, sub-base 5. That comes in very predominantly in your indigenous peoples. Mayan, Aztec, Inupiaq, Yupik, and your Plains Indians as well. With me? Okay. So, let's see. We're going to talk more next week about how to do expanded form. I specifically have it on one of our activities we're going to look at, so I'm going to kind of skip this for now because we can kind of there's a whole bunch of them. We can lose a lot of time with it. So what I would like to do right now is work with these base 10 blocks. You guys have them all in front of you, right? So your little tiny ones are your units or your ones. These ones, what did you guys call them in your school? Rods or longs? Rods. I've always called them rods. Everyone in my school in Alaska called them rods, but a lot of schools and oh, dang it, that should have highlighted up the name. A lot of people and a lot of books will also call them longs. So if you see a long or a rod, it's the same thing. It's 10. Then we have this one. What do we call this one? Flat. That's our flat. And then I always called this one a brick in class to separate it from a base 10 block. Because some teachers would still call this one a block, and then when I'd say, go get your base 10 blocks, never fail, I'd always have 1 or 2 students that had just come back with just the thousands. Because they were like, well, you said blocks. Sense the confusion there? So, we have units or ones, longs or rods, flats tends to be universal, bricks or blocks. Ones place, tens place, hundreds place, thousands place. The important thing to remember here, I want everybody to take a really big deep breath, and I want you to try your hardest for the rest of your life not to say the words borrow or carry. Okay? Everybody take a deep breath. Because the words borrow and carry were invented to describe a motion in an algorithm that was taught to math students 100 years ago. Those students were not taught why that worked or what was actually going on, and it has no mathematical meaning. So it doesn't support our work as teachers trying to teach our kids how to understand this base system. The words borrow and carry don't help. So I would like for everyone right now to try to replace those 2 words in your vocabulary with trade or exchange. Because what is literally going on in the base system is traditionally, if you were borrowing from the tens place to the ones place, what you are literally doing is exchanging one of your rods for 10 ones. You're trading. That's all you're doing. Is you're trading one of these for 10 of these on your paper. So if you replace those 2 words with trade and exchange, then what you do is you build on your students' concrete understanding of what is going on as they lose these manipulatives and grow older through the grades. Now, my students always come back to me and say, Ms. Stockton, I got a new job, and I'll tell you, all those women in that hallway say borrow and trade. And I'm like, I know, darling. I know they do. Because this method of teaching math has really only been around for the last 10 years. I mean, it's been around longer, but we've only started doing it for you for 10 years. Up to that point, our elementary teachers did not not get this training. We just assumed if you could borrow and carry, you knew this. And not everybody knows the intricacies of how this works. So that's the reason that we break it down now. So when you get out there, yes, you're still gonna have the older teachers down the hall saying borrow and carry, okay? They were taught before we taught this way. Doesn't make them wrong. It just know that in your classroom, the words you're using are supporting the big idea of the math content that your kiddos are learning. Make sense? Okay. That's important, because if you put borrow and carry on your test, I'm very big. Okay, so what number would you first create this number for me? Can you create it? Talk about it with your table mates. I will bring around the bricks. There's a brick. Oh, you got a brick, don't you? This group, did you guys have a brick? No, here's a brick. I'll bring you that brick. Oh, you still need one? You did. I remember seeing one. All right. Oh, the gift is like one. No, I was trying to give it enough so you guys could do it. Oh, 11. 11. That's what you guys do. I was like, these are like a black blue, and these are light blue, and these are tan, and that orange. I was like, had the bricks off by themselves. Okay, so how many blocks do we have in the thousands place? How many blocks do we have in the hundreds place? How many blocks in the tens place? And how many blocks in the ones place? Okay, so the reason that we put this up there is to demonstrate to our students that although the digits are all the same, 1, 1, 1, 1, the value of each digit is different. What determines how much or the value of that digit? Like, what makes this one a different value than this one? Yeah, but why is it bigger? It's you are both correct. The quantity is bigger. That is its value. But why, if I draw a 1 right there and I draw a 1 right there, how do you explain to your kids that this one is not worth the same amount as this one? Let me give you the answer. It's location. It's location in the number. Every digit, that is literally, that's place value. Its place in the number determines its value. The word place value, literally, that's what it means. So, every one in this one is worth this many. So if we have a 3, we have 3 of those, right? If we have a 4 in this place value, it means we have 4 flats, which is a value, or it's worth how much? 400. That's the crux of place value. Its location determines its value. You with me? Okay. So, go. So what about this one? What would each of these digits be? Go ahead and build it. Taylor's eyeballing it over there. You need to borrow my one contact lens?
I know, I was like, close my eyes and see.
I know, counting those. Alright, so we have how many flats? 3, which gives us a value of 300. Perfect. And we have how many rods?
3.
Which gives us a value of 30. And then we have how many ones?
6.
Which gives us a value of
6.
Okay, when you write out the values, learn at second grade. Okay, the very, when they just write out their values, very basic form of expanded form. Second grade there. I don't wanna do all this. Hold on. I wanna get to this one. All right, can you do this for me? Represent 612 with base 10 blocks, but do it in more than one way. Man, I'm really missing my coffee this morning. Okay, so generally people make the one with the least amount of blocks first. The least amount of blocks would be how many flats? 6 flats. So normally if you draw these out, that's really all we're going for here, 6 flats. Looks something like a square. Then, how many rods? 1 rod. Normally when we do rods, we just use a straight bar when we draw it. And then, how many ones? 2 ones? So there is 612. How else could we make 612? Can somebody give me another way?
12 ones and 6.
Perfect, okay. So, back there I have 6 flats. And then, let's practice using our teacher talk. This is the least. How did you get 12 ones? What did you do right here? We exchanged what? We exchanged, be specific, 1 rod for 10 blocks, or 10 ones. Good. So we'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We tried to put them in like groups of 5 on a 10 frame for them so they can see them in 5s. So there's another way. Is that the only way we could do it?
No.
We could have what? Traded in flats. We could have traded flats for rods if we wanted, or flats for rods and rods for ones. We could have done it a multitude of ways, correct? Okay. So the reason we do that is because today we've got a little problem solving activity. You're going to play a game with your partner where you're going to use your base 10 blocks and the clues given on here. Ooh, turn it upside down, sorry. For coming up with answers to these 8 questions. There are more than one right answer on some of them, okay? So you guys are gonna play with your base 10 blocks and these clues.